Hello, beautiful family. How you doing? My name is Mutwana. Without further ado, let's get started. So, let's say you have this question here, right here. Let's say, in the graph of, but it didn't show us a graph, okay? But let's say this graph is gonna pass through these coordinates. The value of b is, they want to get the value of b, okay? So look, whenever the coordinate pass through the graph, like let's assume, for example, if somebody give you any, like let's say quadratic, let's assume quadratic. Let's say you have a quadratic graph. Let's assume you have a quadratic graph. If we have any points, let's say here point, let's say this point 2 and 3. If this point lies on the graph, let's say y equal to x squared. If it's true this point lies on the graph, when you substitute, it must give you true answer. Look, they must be equal. For example, what the value of y? Y equal to 3 equal to what the x? X equal to 2 but a square. So we have a 3. Is 3 equal to 4? No, it's not equal to 4. So in that case, this coordinate here does not lie on this graph. Now let's come to the question here. So for this case here, they say you have your graph, but this is a logarithm graph. They say you have a point which passes through this point pass through this graph. But now they say you have to find the value of b. So now how are you going to get the value of b? Is very, very easy. Let me show you quick. It's very easy to get the value of b. How are you going to get there? Look here. How are you going to get the value of b? Look. So what we're going to do here, you have to be familiar with the exponential rule. What is the exponential rule? For example, if somebody give you x equal to log, let's say this is k and this is t. Apply exponential rule. How you apply exponential rule? You push. You see this k here? You push, is going to come here. It's going to become k. And you see this one here? Is going to go to the top. And then you write your equal sign. So what you left on the right? Your left side, you left with a log in it and a t, because k went to the left. So this log is going to disappear. So when it disappears, you're only going to write t. Oh. So now, if you have to change all this stuff to exponential rule, this is what we're going to get. That's why we call it the exponential rule, because it starts from logarithm and then it went to the exponential. Okay, just one more example. So if somebody give you, for example, let's say, let somebody give you log 2x and let's say anything. Okay, let's say t equal to 0. Face, can you apply exponential rule? Yes, because the question is, how do you know exponential rule? Exponential rule, you only apply when you have a log on one side. We have a log on one side, and this side here should be number. Okay, you only that we call it exponential rule. Then you can apply exponential rule. Only have a log on one side, and then the other side equal to number. So for that case, now I'm going to put this to the right. So here I'm going to be left with 2x equal. This t is going to come to the right, and this 0 is going to become as a power. But any number power 0 equal to 1. So t power 0 equal to 1 equal to 2x. So we can get the value of x here. Divided by 2, divided by 2. This cancel. So finally, the value of x equal to half. That's how you can apply exponential rule. So for that case, now if you look careful, in this example, realize we have a log on one side. Oh yes, we have a log on one side, which is the right. Okay? Excuse me. So what we can do, we can apply exponential rule. Or let me plug face the value which is given. But whenever you have a coordinate, it means this is x and this is y. Whenever you're given a coordinate, it means the first one is x, the second. So in the position of y, you're going to plug what? 2. So say, for that case, that's going to become 2. Equal means you replace this with a value of y. Equal. Log. B, do you know b? Nah, b is what we're looking for. So I'm going to write here b. And we know the value of x. Oh yes, a normal value of x. What the value of x? This is the value of x. So in the position of x, I'm going to write what? 8. Oh, so then what's value then? Then I can get the value of b. Because what I will do, I'll push this to the left. Because why do I apply exponential rule? I apply exponential rule because I have a log on one side. Push to the left. When you push to the left, this is going to become b power 2 equal. So this log is going to disappear just like how we did before. So we only left to the 8. So now what we're going to do here, I can simply square root and square root both sides. So when you square root b, this and this is going to go. So b equal. When you square root 8, it's going to give you 2 square root of 2. And I can show you there. Just a second. Okay, now let's prove that So we're going to say square root. I got my calculator. Square root of what of? So we're going to say, let's square root. So we're going to say square root of 8, right? So square root of 80, and that gives us 2 square root of 2. Oh, so for that case now, our answer here is 2 square root of 2. Okay, well, so all this stuff here, the value of b equal to 2 square root of 2. So look, before we go further, right, if you face some in this program, make sure you come right here, Femi. Make sure you come and you subscribe right here. Click subscribe and subscribe right now. Okay, subscribe if you have not yet. Okay, but if you already subscribed before, now it's fine. You don't have to do twice because it means you're gonna unsubscribe, which is not supposed to be like that. You're gonna miss it. Now let's go to this next question. That question done already. Now we come to this question here, very interesting question. So this question here, they say there's a 3 workers, okay, on the same job. Show the following result over a long period of time. Okay, so we have 3 workers here. The first worker is Mpo, Tumelo, and Simpiwe, and they give us a mean. So this one is a mean. This is a mean. The first one, a mean, and the second one is standard deviation. Means these are standard deviation here. You can see here. These are mean, and these are standard deviation. Now, what do you want? They say calculate this coefficient of variation of time of each worker, and then after, okay, so let's get the coefficient of variation. After we get coefficient of variation, and then we're going to compare which is more consistent one. Okay, but we get coefficient of variation is very, very easy, way easy. Okay, we get coefficient of variation is very easy. Sorry, I had to. Okay, so to get the coefficient of variation is very, very easy. How we get the coefficient of variation? So we're going to say, let me just drag this calculator face to the right so you can see here what they say. Oh my God, sorry, family. Yeah, let's just put it here for now. And now drag it, okay? So now, they say you have to find the coefficients of variation, which is very easy. So I'm going to say, let's get a coefficient of variation. So I'm going to say to get coefficient of variation, find the coefficient of variation. So I'm going to say, let's start with the face. So let's start with the Mpo face. Mpo. So we're going to say coefficient of variation, coefficients of variation of Mpo, let's say of M, equal. So what you do, you take standard deviation of Mpo, means this one here. You divide by the mean of Mpo, which is 25. So we can say divided by the mean Mpo. So what is standard? And then we multiply by 100%. That's how you get the coefficient of variation, CV coefficient, because they say find the coefficient of variation. So now I'm going to say, what is standard deviation? Excuse me, equal to 6 over 25, and then you multiply by 100%. So this is going to give us, okay, so I'll take in a calculator, come quick in a calculator. Okay, so let's come in a calculator. Okay, plug in a calculator quick here. So plug in a calculator, we're going to say what? Choose, okay. Clear there. So we say fraction is fraction. Now we say 6 over 25. Come down, say 25. Say 25, and then come here, and then you multiply by 100%. Multiply by 100%. Percent shifty, and this a percent. Okay. So for, okay, let's put in SD in a decimal. So it's gonna give us 0.24%. Okay. So for Umpo, now we know. For standard deviation for Umpo, we know 0.24%. Oh, 0.24%. So we're going to say Umpo equal to 0.24%. Now, let's do for Tumelo. So for Tumelo, let's say coefficient of variation for Tumelo. So for Tumelo, is going to be, we're going to play the same game. I'll say 7 over 24 because we must take a standard deviation over mean. 7 over 24. So we come here and say 7 over 24. So we say 7 over 24. So I'm not going to do everything. I'll just come, simply say 24 there, and then delete 24, and then we go to the top, and then I'll delete that one and put 7. Okay? And then this is going to give us 0.29, 0 to 9. Okay. So 0 to 9, coefficient of variation of the tumelo. 0 to 9. So 0 to 9%. Okay, now let's go for the last one. For the last one, Simpiwe. Okay, let's go for Simpiwe. So for Simpiwe, we're going to say 5 over 19. Excuse me, 5 over 19. 5 over 19. Okay. Okay, come there and say 5 over 19. So 5 over 19. And then we're going to multiply, or multiply by 100. So look, 100%, 100. So this one get, I forgot to say percent. Shifting. Oh my God, sorry. Because I don't want to put percent, so even this must have a percent. Okay. Okay, that's want to take it. Okay, sometime I give it. Okay, no problem. Let's plug again quick. So we say 0.29. Okay, we say 5, and then over 19, which is this one, 19 over 19. And then you come here, you multiply 100 and the shifting percent. So if you plug in a percent, it's going to give us 0.26. So for that case, okay, so Simpiwe 0.26. So we're going to say coefficient of variation of Simpiwe, coefficient of variation of Simpiwe equal to 0.26%. So look, they ask here which is more consistent. So the consistent is always the smallest one. So the smallest one, if you look careful, is for mpo. So this is going to be consistent. If they ask which one is more fastest, you take the smallest coefficients of variation. Or the consistency, the same thing, you take the smaller one. See? So more consistent. So sometimes they say consistent, sometimes they say smallest one. They say fastest. Oh my God. Sorry. If they ask consistent, sometimes they say fastest. So what you do, take the smallest one here. The weka that appear to be more consistent to complete the job. So what you do, come right here, compare all of those coefficients of variation, take the smallest one. That's your answer. So the consistency for this case is going to be 0.24. That's going to be the mpo. So our answer is going to be mpo. Okay, so we're done with our question. Now we go to the next one. So the next one is very easy. So we play the same game. This is very similar to the previous. So they say, oh, we have a worker do the same job. And now they say this worker do the same job. Okay, let me drag my calculator to the top. Put the calculator there. Okay, now we go, they say, let's go. Now let's say here, we have a worker and this worker do the same job. But what happened? They give us a mean. So this is a mean and this is a standard deviation. We represent by this sign here. That's standard deviation. So we do the same game. Which worker is more faster to complete the job? So what we're going to do, find the coefficient of variation. And after getting the coefficient of variation, take the smallest one. That's our answer. So what we're going to do, we're going to say 9. Let's start for worker P. So worker P, coefficient of variation of worker P equal to 9 over 33 times 100%. Or you can say 100 if you want, or you can put percent, whatever. Okay, so we plug this in the calculator. And this is going to give us 9 over 33 times 100. 9 over 33 times 100. So we say 9 over 33 times 100. You say 9. Count fraction here, 9. 9 over 33. If you got a calculator also, try to see what you're going to get. So we see we can compare 33 times 100. Okay, so the first worker give us 27. Okay, 27.27. You can write down if you want. So 27.27. Okay, the second one, we're going to say, okay, the second one I cannot see there. So I'm going to have to, okay, the second one we're going to say, okay, let's write down. So is the first one is 27 point, bigga. It was 27.27. Let's write down so we're not going to forget. 27.27. So we're going to say for worker P, this is going to be coefficient of variation. Worker P equal to 27.27, if I'm not mistaken. Now we go for coefficient of variation of worker Q. Okay, so for worker Q, okay, let's count for worker Q now. So for worker Q, we're gonna say, what is a worker Q? Oh, worker Q. Can you guys see worker Q? 7 over 27. Okay, 7 over 27. Okay, 7 over 27. So we come here, we say 7 over 27. Oh, fraction 7 over 27 over 27. Then we come multiply by 100. By 100, no, not 1,000. Okay. So plug in a calculator and get your answer, and then we see this is 25. So this is more smaller. So if the coefficient is very smaller, then that's going to be your faster one. No, when the coefficient is very smaller, if you go to the question, like they say, which way can be faster to complete the job? So you check the smaller one. Okay, so I'm going to say, for that case, the other one will get 25, right? If I'm not mistaken. So let us, so the other one is 25, if I'm not mistaken. 25 point something. Okay, check it. 25.9 something. So now they say here, which worker seems to be faster in completing the job? So the smaller coefficients of variation, that's the one which is going to complete faster. Or sometimes you can say this is a consistency. But if they say which worker is going to complete slower, and then you come here, you pick the coefficients of variation, which is bigger. It's like the other way around. So look, some of you might be new here, right? Make sure you go there, right here, subscribe to our beautiful channel here. Subscribe, please. Make sure you subscribe. Subscribe. And then, just something quick. Okay. So make sure you come and subscribe to our channel. Okay. Subscribe to our channel here if you have not yet. And I'll see you very soon. And just one thing, okay? Cool. So just subscribe, man. And I'll see you very, very soon.